Hello everyone. In this video, we will work with triangular waves and its Fourier series. Let's take a look at function f(x). And in this function f(x), it's already given to me as a over pi squared multiplied by all of this term of sine inside the brackets. So note that we only work with sine term in this case, and we are dealing with odd harmonics. Okay, so let's examine how this wave behaves in terms of the sine wave and its Fourier series. So first of all, if I have just one term for f(x), it's obviously that you see is a sine wave. Then I add more terms to this. I add 1 over 9 sine of 3x, or I should say I add negative 1 over 9 sine of 3x. You see that is the tip of this sine wave is getting sharper. So I add another terms. Okay, you see the change in the behavior of this sine wave. Okay, so just keep in mind that I work with, just take a look at this part here. Keep in mind that I just work with 1 and 2, alright? So, and then we are examined from 0 to 10 in this case. And then the next one, you see, is getting sharper. But I still go between 0 and 10. Okay. So, to let everyone know that it's getting just sharper and sharper each time. But so it doesn't increase the amount of the sine that I have, but it's getting sharper each time. Okay, so I still have 2 to work with. So it's getting sharper, and it's getting sharper as well, until I can see that I can make a straight line and it turned into a triangular wave. Okay, so this one I add one more. Okay, I add another one. Okay, I still show you that this still the sine wave in this cycle from 0 to 10, but I hope that you realize that it's getting sharper at its top. I can just go ahead and use a ruler and connect them. Okay, I add another term here, and I add another term here. Okay, so you see this part that I have really a straight line. So now obviously at this point I see that I have a triangular wave. Alright, okay, and the next point I would like everyone to note is this. Okay, so notice this right here, the maximum values or the peak of this is 0.8. This one I'm getting it higher than 0.8 and even higher than 0.8, higher than 0.8, higher than 0.8. Okay, until I see that I'm reaching the value almost equal to 1. Alright, okay. So what do you notice about the gradually change in each way? The answer is the first sine wave f(x) equal to 8 over pi squared times sine of x is at 0.8 as peak value. The graph with more term gradually increases to reach f(x) equal to 1. The tip is getting sharper with more term until it's formed as an obvious triangular wave. Alright, okay, so let's move on to the next wave. Okay, so you see that I now graph this triangular wave, but I move it over to this part. Okay, I move it over here and I put it in the interval of 0 to pi to 2 pi. So right here is my 2 pi, right here is pi, right here is pi over 2. This is 0. This is the negative pi over 2. Alright, okay. So it's given to me as this waveform is even and it has half-wave symmetry. Therefore, the Fourier series has only cosine term and odd harmonics. Okay, so let's get back to our formula sheet. Okay, that confirm this information. Okay, so this one is odd. So it's odd, so it has the sine term. But in this case, we identified it as even. Okay, so I'm sorry, I should say that is equal to, it's an even function. Therefore, it has only the cosine term and it's half-wave symmetry. Therefore, it's only at the odd harmonics. Okay. So this question asks me slightly different from what I have to do earlier in previous lesson, that it giving me the fx, which is giving me the Fourier series already. Okay, it's giving me the Fourier series already, and it's given me in this form. It's given it to me as the summation, and all I have to do is just expand this summation and give the expand version of this Fourier series. So let's work with this. I don't have to do any integration in this point. It's already given to me, and all I have to do just write is 5 terms. Okay, so let's get started. Okay, so I will rewrite the summation. Okay, so here I already rewrite the summation for everyone, and I will start with the n. So don't forget that n is given to me as this. Okay, so 5 terms, right? 5 terms. So this n here is the n of the summation. So I'm going to set n equal to 0. So n equal to 0, 1, 2, 3, 4. So 1, 2, 3, 4, 5. So it's 5 terms. So that's one. That's why I have n equal to 0, 2, 4. So when you set n equal to 0, you are going to substitute 0 into where you find the n is. Alright? Okay. So when equal to 0, I will have a over pi square, and then I will write this one as 1 over 2 times 0 plus 1, all of it square, times cos of 2 times 0 plus 1 of x, and close the bracket. Okay, so then I will have a over pi square, and what do I have in this case? Okay, so I should have 2 times 0 is 0, 1 over 1 is just 1, so in this case I should have 1. Here I should have cos of 1x, okay, cos of 1x, so let's leave it like that. So I will write a over pi square and cos of x. Alright, okay, so let's circle this. This is term number 1 that I found when n equal to 0. Now n equal to 1, then I do the same thing. I will put it in here, a over pi square multiplied by 1 over 2 times 1 plus 1, all of it square, multiplied by cos of 2 times 1 plus 1 of x, close the bracket. So I will have a over pi square. This one I should have 2 times 1 is 2, 2 plus 1 is 3, 3 square I should have 1 over 9 and cos of 3x. Alright, okay. So I should write this one as a over pi square and bring the 9 and put it at the front, and I will have cos of 3x. Alright, so let's circle this again. Okay, continue on. I will write n equal to 2, then pi square 1 over 2 times 2 plus 1 square, okay, times cos of 2 times 2 plus 1 of x. Alright, close the bracket. I should have this one equal to a over pi square, and inside the bracket 2 times 2 is 4 plus 1 is 5. 5 squared should be 1 over 25 here, and I should have cos of 5x. Alright, so this I will write it as 8 over 25 of pi square and multiply by cos of 5x. Okay, again, we circle this. Now continue on to calculate n equal to 3. So a over pi square, and I should have 1 over 2 times 3 plus 1 all of it square times cos of 2 times 3 plus 1 of x, close the bracket. So I should have a over pi square. In this case, you see that I will have 1 over 2 times 3 is 6 plus 1 is 7, so this is 49, and cos of 7x. So it's equal to 8 over 49 pi square cos of 7x. Okay, again, we circle this. Okay, so now n equal to 4, we are almost there. A over pi square 1 over 2 times 4 plus 1 all of it square cos of 2 times 4 plus 1, and here's x. Alright, okay, so a over pi square. In this one I should have 1 over 2 times 4 is 8 plus 1 is 9. 9 square I should have 81 cos of 9x. Okay, so let's write this one as 8 over 81 pi square cos of 9x. Alright, so let's go back and recap what we just did. Okay, so this Fourier series is already given to us, and they give us in the summation term, and the n from 0 to 4 belongs to the summation, and what we have to do is we identify n as from 0, 1, 2, 3, 4, and we substitute into this equation and we expand them, and we have all of this term. Okay, so we have this, we have this, we have this, we have this, we have this. So the question asks us that we have to write the expansion of fx, so I will write fx equal to, okay, so I will write excuse me, a over pi square times cos of 1x. Okay, so I want you to note that this is the 1 and this is the 1, and I'm going to add that with another 8 over, so 9 pi square, and here is cos of 3x. Alright, so now you see this one is the square, 3, and that is the square of 3. Okay, and the next term I should write is 8 over 25 pi square cos of 5x, then plus 8 over 49 pi square cos of 7x, plus 8 over 81 pi square cos of 9x. So now you notice that this is the 9, the square of 9, the 7, square of 7, the 5, and the square of 5. Okay, in the end, what I do is I will factor out the 8 over pi square. So inside the brackets, I left with cos of x plus cos of 3x divided by 9 plus cos of 5x divided by 25 plus cos of 7x divided by 49 plus cos of 9x divided by 81. Okay, so there it is. Alright, okay, so let's recap what we have. Here is my A1. Okay, here is my A3. Here is my A5. Here is my A7. And here is my A9. Alright, okay. So this is the A9. Okay. So what do we have to conclude in this case? Okay, so I would like everyone to take a look at our Fourier formulas. Okay, so in this Fourier formula that's given to us, okay, see right here that we have summation of term involving the A and term involving the B. But in this question, it's given to us as even and half weight. Okay, so even is right here and halfway, so we only have cosine term and the odd harmonics of the cos term. So that means I can eliminate that. I can eliminate all of that, and I only have my odd harmonics, so I will have that, I have that, and I continue to have a 5 or cos of 5x. I don't have this in this case, and according to the equation that given to me, I found it as a over pi square and all of this term inside the brackets. Alright, thank you.